Hello and welcome to Chapter 6. In Chapter 6 we will learn to factor. We'll start by factoring out a greatest common factor. We'll take a look at that idea from the distributive property. Say for example I have 2x times 4x plus 3. If I distribute this 2x into my binomial, I have 2x times 4x or 8x squared and 2x times 3 plus 6x. Now this new binomial here has a common factor of 2x in each of the terms, meaning that now both of these terms are divisible by 2x. So our goal with factoring is to start with something like this binomial here, 8x squared plus 6x, and come back to this original problem, 2x times 4x plus 3. So this will be factoring out our greatest common factor. So first we have to be able to recognize what our greatest common factor is. We can do so by taking a look here at our numbers 8 and 6 and recognizing that the greatest common factor of 8 and 6 is 2. We'll recognize that the same way we do with fractions. For example, if I had 6/8 and I wanted to reduce this fraction, I'd recognize that each of those had a common factor of 2 that I could pull out, giving me 3/4. Same thing here. I can recognize that both the 8 and the 6 have a common factor of 2, and I'll pull that out. And then here, taking a look at my variables, I have an x squared and an x. X squared is x times x, and x here is just x. They each have a factor of x that I can pull out. So I'll pull out that factor of x. This leaves me with, if I take out the 2 from the 8, it leaves me with a 4, and I have one factor of x left. And then here, take out that factor of 2 from 6, that leaves me with a 3, and that factor of x here has been taken out, so there's nothing left here, and I'm done. So that is factoring out our greatest common factor, and we ended up with where we started. So let's try this with another problem. Let's say I have 15x cubed plus 10x. So in this case, again, I'm looking for the greatest common factor. The greatest common factor in 15 and 10. So the largest number that will go into both of them, that will divide into both of them. That number is 5. So we pull out that factor of 5 from each of those. Pull that out front. And then here we take a look at our variables. Again, x cubed is the same as x times x times x. And here we just have one x, so we have one factor of x that we can pull out. One thing to note here is our factor of x that we pull out is always going to be the same as our lowest power of x. So here we had an x cubed and an x to the first. X to the first is what we'll be able to pull out of each of those terms. So we have 5x. Pulling out that 5x from each term, 15x cubed. Dividing out that 5 leaves me with 3. Dividing out the x leaves me with 2 factors of x left, or x squared. Dividing out the 5x for my 10x, I'm left with plus 2. So this then is my factored form. I have factored out the greatest common factor. Let's try one more of these. Let's say I have 2x squared y squared plus 4xy cubed. Here again I'm going to look for the greatest common factor of my coefficients, 2 and 4, greatest common factor being 2, which I will pull out. Then pulling out a factor of x. This term here has a factor of x to the first and x squared. And I pull out the smaller factor, so x to the first. And then here y squared and y cubed. Again, I'll pull out the smallest factor, y squared. So pulling this term, this greatest common factor, out of each of these terms, right? 2, pulling out that 2 leaves me with a factor of 1, x squared. Taking out an x leaves me with 1x left. And I do not need to write that coefficient of 1, I can just leave it as x. And then y squared, pulling out that y squared, so no more y squared in that term. Next, Pulling that factor of 2 out of 4, I have plus 2. Pulling out my x, so there's no more x. And then pulling out our y squared from our y cubed. Right, this is the same as y cubed divided by y squared, which just leaves me with y to the first. So this then is my factored form, and we can verify that this is indeed the correct factorization. If I were to distribute this again, I should get back what I started with. So here 2xy squared times x gives me 2x squared y squared, and then 2xy squared times 2y gives me plus 4xy cubed, which is exactly what we started with. So this indeed was the correct factorization. So this is our answer. Next we'll take a look at how to factor by grouping. Say I have 5x times x plus 3 plus 6 times x plus 3. The central idea to factoring by grouping is to recognize this binomial, x plus 3, as a factor in these two pieces. Here we have 5x times x plus 3 and 6 times x plus 3. So x plus 3 I can think of, right, as my common factor for these two pieces. So I can factor out that common factor of x plus 3. So I factor out my x plus 3. Right, if I pull out an x plus 3 from this term, I'm left with just my 5x. So I multiply that by my 5x. And then I factor out the x plus 3 from this term, leaving me with just my 6, so plus 6. So this is the same as factoring out my greatest common factor, now just recognizing a greatest common factor as a binomial. So let's try to factor by grouping with this polynomial. We'll take 2x cubed minus 4x squared minus 3x plus 6. So in order to factor this by grouping, I want to rearrange it so that it again has binomials that are the same in two different pieces. So to do that, I will group my first two terms and my last two terms, making sure to include the sign of this term here. Now to remind myself that I'm not now multiplying these two pieces, I'm going to put a little plus sign in here to remind myself I'm not multiplying these binomials, I just grouped those terms. So what I want to do then is factor out the greatest common factor of the first two terms here, and then factor out the greatest common factor of this second grouping. So first here, my greatest common factor is a 2x squared. So I'll pull out my 2x squared. That leaves me with x minus 2. Here, my greatest common factor is going to be a negative 3. Now I want to pull out a negative 3 because I want the first term of my binomial to be positive x. Right? I want the binomial to be the exact same, and if I pull out that negative 3, I know that I'll be at least starting in the right place. So I factor out a negative 3, and that leaves me with x minus 2. So now I have that same binomial in each of these two pieces. Right? I have the x minus 2 here and here. So I can factor out that x minus 2. I pull out my x minus 2 out front, and then what is left in the second parentheses here are my 2x squared minus 3. So this then is my final factored form and my final answer. Let's try one more. Let's do 2x to the 5th minus 8x to the 4th plus 6x cubed minus 24x squared. So before I group my first two terms and my last two terms, the first thing I usually want to look for is a greatest common factor through all four terms. I recognize here 2, 8, 6, and 24 all have a common factor of 2 that I can pull out, and they all have a factor of x squared that I can pull out. That leaves me with my new polynomial now of x cubed minus 4x squared plus 3x minus 12. Now I can group the first two terms and last two terms of this polynomial and find my greatest common factor for those two groupings. Here I have a common factor of x squared, which leaves me with x minus 4. And here I have a common factor of 3, so plus 3 times what's left, my x minus 4. And this, of course, is all still being multiplied by my 2x squared, my greatest common factor. Now I want to finish up my factoring inside here. I have that common factor of x minus 4, so I factor out that x minus 4, which leaves me with an x squared plus 3. This, of course, is still being multiplied by my 2x squared, my greatest common factor, and then this is my final answer. It has now been completely factored. So again, usually the first thing we will always want to look for is a greatest common factor in our original polynomial. In our previous example, we did not have a greatest common factor, so it was okay that we just started by grouping. Next, we'll take a look at factoring trinomials. Factoring trinomials in this form: x squared plus bx plus c, where we have a coefficient of 1 for our x squared term. It could help if we first take a look at x plus m times x plus n. If we go ahead and distribute this, we have x times x, or x squared. X times n gives me nx. M times x gives me mx. And m times n, so I have mn. I can combine these like terms a little bit with some factoring. I recognize here I have a common factor of x. This can be written as plus m plus n times x plus mn. So the reason I write it like this is so that we can see in general our last term here is going to be the product of these two last terms, or the two second terms in each of the binomials, and that the number in the middle here, right, our coefficient for our middle term, is going to be the addition of those two terms. So when we are looking at something like x squared plus 5x plus 4, what we need to know is when we go to factor this, those last two terms here, right, will be factors of this third term, and those two numbers will add up to our middle term. So if we are factoring this, right, we need to find factors of 4 that will add up to 5. So for example, factors of 4 are 2 and 2 and 4 and 1. These two factors add up to give me 4, and these add up to give me 5. So the two factors I'm looking for are 4 and 1. Right, what that tells me is that the factorization of this trinomial is x plus 4 times x plus 1. Alright, again, those last two terms in each of these binomials multiply to give me my third term and add up to give me my middle term. If I distribute this, I should get back that trinomial. I have x times x, which is x squared. X times 1 gives me x. 4 times x, 4x, and 4 times 1 gives me 4. I add my two middle terms, and I have x squared plus 5x plus 4. So indeed, I get back what I started with. So x plus 4 times x plus 1 was the correct factorization. The thing to remember here is anytime I have a coefficient of 1 in front of my x squared term, my first two terms will always just be x. They won't have a coefficient, because when I multiply them together, I want to get 1x squared. So for this type of trinomial where our coefficient is 1, our first two terms are always x, and our second two terms, right, multiply to give me my third term in the trinomial, and add up to give me the coefficient of my middle term in the trinomial. Let's try this with another trinomial. Let's say we have x squared minus 7x plus 10. Again, all of the trinomials we're taking a look at right now have a coefficient of 1 for our x squared term. So now I'm looking for factors of 10 that will add up to a negative 7. Factors of 10 are 10 and 1, 5 and 2. These two add up to give me 11, and these add up to give me 7. Well, these are both positive. What I want is a negative. Well, what we can consider then is negative 10 times a negative 1, right, gives me a positive 10, and when I add them gives me a negative 11. Negative 5 times a negative 2 give me a positive 10, and they add up to give me a negative 7. So if my positive factors don't work, I can consider the negative factors. So here I'm looking at negative 5 and a negative 2, because they multiply to give me my third term and add up to give me the coefficient of my middle term. So when I factor this, right, I can set it up. Right away I know my first two terms are x, and then my second two terms will be a negative 5 and a negative 2. Right, I can then again check this. When I multiply, I get x squared minus 2x minus 5x plus 10. I add my middle terms and I get x squared minus 7x plus 10. Okay, so this then is my final answer, x minus 5 times x minus 2. Next, let's take a look at 2x to the fourth minus 4x cubed minus 6x squared. Now the first thing we'll notice here is we do not have a coefficient of 1 in front of our first term, but we have to remember that the first thing we should always be looking for is a greatest common factor for every term. We do have a greatest common factor here. Our coefficients have a factor of 2 that I can pull out, and our variables have a factor of x squared that I can pull out. This leaves me with x squared minus 2x minus 3. Now I have a trinomial here with a coefficient of 1, so I can use the new rules I just learned on how to factor this to factor that trinomial. So I'm looking for factors of negative 3 that will add up to a negative 2. Factors of negative 3 are negative 3 and 1, and 3 and negative 1. These add up to a negative 2, whereas these add up to a positive 2. So what I'm looking for is these first two, the negative 3 and positive 1. So I have here x minus 3 times x plus 1. And then I can't forget my greatest common factor of 2x squared, which just stays out front. So if I were to then take this and distribute everything, right, multiply those binomials back together and then distribute my greatest common factor, I will get back what I started with. So this is my factored form. Lastly, we'll take a look at factoring trinomials in this form, ax squared plus bx plus c, where now we do have a coefficient in front of our x squared term. That would be something like 2x squared plus 7x plus 3. So in this case we have to take into account what that 2 will do. Since there is no greatest common factor, and we won't be able to pull out that 2, so we have to take it into account. So here what we're going to do is a slightly different method to factoring by grouping. We're going to take this first coefficient and our last coefficient, 2 times 3, to give me 6. And then I'm going to look for factors of 6 now that add up to 7. So factors of 6 are 2 and 3, and 6 and 1. These add up to 5, or 6 and 1 add up to 7. So what I'm going to do then is I'm going to split this middle term. Instead of writing it as 7x, I will split it up into a 6x and a 1x. This gives me 2x squared plus 6x plus x plus 3. Now the reason I do this is now I have 4 terms, and I can go back to our earlier method of factoring by grouping. So I can group my first 2 terms and my last 2 terms, and then look for greatest common factors in each of those pieces. So 2x squared plus 6x has a common factor of 2x, which leaves me with x plus 3. Now here, this is x plus 3, it has no common factor, so I can just bring it down as plus x plus 3. Now what I see here is that common binomial of x plus 3 that I can factor out. So I pull out that x plus 3, and that leaves me with here a 2x plus, now when I pull out that x plus 3 here, I'm dividing x plus 3 by x plus 3, which leaves me with a factor of 1. So I have x plus 3 times 2x plus 1, and if I want to check this, I can go ahead and distribute. This gives me 2x squared plus x plus 6x plus 3. If I add those 2 middle terms, I get back my 7x. So indeed, this is the correct factored form of that original trinomial. So again, the trick here, multiply the first coefficient by the last coefficient, and then find factors of that number that add up to our middle number, so we can split that middle term and factor by grouping. We'll try this again. Let's try 3x squared plus x minus 2. So again, this time I take my 3 times my negative 2, which gives me negative 6. And I find factors of negative 6 that add up to a positive 1. Factors of negative 6 are negative 6 and 1, 6 and negative 1, 2 and negative 3, negative 2 and positive 3. I check to see which of these add up to that positive 1. Here I have negative 5, 5, negative 1, and 1. So I'm going to use this last pair here, negative 2 and positive 3, to separate this middle term. So now I have 3x squared. That 1x becomes a negative 2x plus 3x. So that when I add them together, I get back that 1x, then minus 2. So here again, I'm going to group my first 2 terms and my last 2 terms, and then pull out a common factor. Here I only have a common factor of x, which leaves me with 3x minus 2. Again, here I have 3x minus 2. There is no common factor, so I just bring down my 3x minus 2. Now I have a common factor here of 3x minus 2. So I pull out my 3x minus 2, and that leaves me with x plus 1. So this then is my factored form. Let's try 2x squared minus 8x minus 3. So here I try 2 times negative 3, which gives me negative 6. So again, I find factors of negative 6 that hopefully add up to a negative 8. So we have negative 6 and 1, 6 and negative 1, 2 and negative 3, and negative 2 and positive 3. I get negative 5 here, 5, negative 1, and 1. None of these are the negative 8 that I am looking for. And there are no other factors of negative 6. This means that this trinomial is prime. Okay, a prime trinomial means it cannot be factored. So we are done with that trinomial. It is prime. Let's try another. Here we will take 15x squared minus 50x minus 40. Again, the first thing we always need to be looking for is a greatest common factor in all of my terms. In this case, I do have a greatest common factor of 5. I can factor that out, leaving me with 3x squared minus 10x minus 8. Now I'm going to factor this trinomial in here. So I'm looking for 3 times negative 8, which gives me a negative 24. And I look for factors of negative 24 that add up to a negative 10. So I have a lot of factors of negative 24. I can do negative 24 and 1, or 24 and negative 1, 12 and negative 2, negative 12 and positive 2, 8 and negative 3, negative 8 and positive 3, negative 6 and a positive 4, or 6 and negative 4. And these are all my factors of negative 24. Looking for the one that adds up to negative 10. And I see here, negative 12 plus 2 gives me my negative 10. So I'm going to split that middle term then into negative 12 and positive 2, keeping my greatest common factor out front. I have 5 times 3x squared minus 12x plus 2x minus 8. Now I'm going to group my first two terms and my last two terms and look for the greatest common factor in those two groupings. So here I have a greatest common factor of 3x, which leaves me with x minus 4. Here I have a greatest common factor of 2, so pull out my 2, and that leaves me with x minus 4. And again, all of this is being multiplied still by my greatest common factor of 5. Now I can see that x minus 4 is my new common factor, so I pull out my x minus 4, and that leaves me with 3x plus 2. Then I again cannot forget my 5 out front. So this then is the factorization of my original trinomial. Sometimes our trinomials can be written a little weird. Let's say I have 1 minus x minus 2x squared. First thing I want to do is write this in descending order, where I have my highest powered term first, going down from there. So I would have negative 2x squared minus x plus 1. So I've rewritten it here. Now when I factor trinomials, I want my first term to usually be positive. If I have a negative term in the first position, I want to factor out that negative term like it's a greatest common factor. Since there is no other greatest common factor, I'm just going to factor out a negative 1. And I can write that as negative times 2x squared plus x minus 1. This is just the standard way of factoring trinomials, always wanting to have that first term, that x squared term, as positive. So just a standardization of factorization. So when we go to actually factor this, again we're looking for 2 times negative 1 gives us negative 2, and factors of negative 2 that add up to a positive 1. So you have negative 2 and 1, and 2 and negative 1. Our second pair here adds up to a positive 1, so we will split that middle term using 2 and negative 1. So we have negative 2x squared plus 2x minus 1x minus 1. I group my first two terms and my last two terms. Again, I always want to make sure I keep that negative sign with my x term. So I'll put a little plus sign in between here. Now I'm looking for the greatest common factor. So my greatest common factor for this first pair is 2x, which leaves me with x plus 1. Here I want to factor out a negative 1, again because I want that first piece to be positive. So factor out my negative, and that leaves me with x plus 1. All of this, again remember, is being multiplied by that negative. That is our common factor. So here I have a common factor of x plus 1. So I pull that out. And that leaves me with 2x minus 1. Again, my common factor of negative is out front. So negative x plus 1 times 2x minus 1. And that is my factorization of this original trinomial. That will do it for the first 3 sections of Chapter 6. Be sure to take notes on this and practice. It is the majority of factoring. Next week we'll take a look at factoring special products as well as just general rules of factoring. We'll review all of those as well as using factoring to solve equations. So make sure you do the homework and quiz, and if you have any questions, feel free to email me or ask them in the discussion board.